Hello students, Mr. Courtney here. In this video we're going to be looking at phase diagrams, and the phase diagram we're going to be using as the example is that of water. We will discuss and interpret a phase diagram for a compound, and as I said, we're going to be using water. We're going to identify the different points on the phase diagram and explain what these different points would mean for any given pure compound. So what is a phase diagram? A phase diagram shows the stable phases of a substance as a function of temperature and pressure. So it describes the conditions and events in a closed system. And that means that no material would escape or no air is present. So in that system, all we have is that pure substance. There is no interference from any air or any other particles, and no material would escape. So we keep in the same amount of the substance within that system. So let's look at the phase diagram for water. Let's identify the different regions on it. We're already given ice, water, and water vapor. So everything here is going to be in the form of a vapor. Everything here will be in the form of a liquid, water, and everything here will be in the form of ice. So when it's ice, that tells us water here under these conditions of temperature and pressure would be a solid. Under these conditions of temperature and pressure, water will be a liquid. And under these conditions of temperature and pressure, water will be a gas. Notice that we have our gas for the phase diagram, we have our temperature plotted on the x-axis and the pressure in atmosphere plotted on the y-axis. Now this is not drawn to scale. Right, so it's not drawn to scale. It's drawn so that we can see the different phases much clearer. Right, it's drawn in that way so we can use it and we can see the different phases under the different conditions of temperature and pressure. So let's look at what happens here. So if we're going from solid to water to liquid, or from liquid to solid, what are these processes called? Well, they're called melting and they're called freezing. So this line here, this line represents a point where water is in equilibrium as a solid and a liquid. So at this point, water exists in equilibrium as a solid and a liquid. Under these conditions of temperature and pressure along this line, water will exist as a solid and a liquid. They're in equilibrium. So that process going from the solid to the liquid is melting, from the liquid to the solid is freezing. That point on the standard temperature and pressure. Standard temperature is 0 degrees Celsius, standard pressure of 1 atmosphere, where it changes from a solid to a liquid. That is going to be our normal freezing or normal melting point. And then we have changes where we go from liquid to gas, which is called vaporization, or we go from a gas to liquid, which is called condensation. So this line here represents the point at which the water exists in equilibrium as a liquid and as a gas under these conditions of temperature and pressure. So water exists as a gas and as a liquid, and they're in equilibrium under these conditions of temperature and pressure. So the point where at standard temperature, at 1 atmosphere, where water is liquid is converted into a gas, that will be our normal boiling point. And the normal boiling point for water is 100 degrees Celsius. So what we're seeing here is that if we, by changing temperature and pressure, you can manipulate your boiling point of water. Okay, and then let's look at what happens when we go from a solid to a gas, or a gas to a solid. Going from a solid to a gas is called sublimation, and going from a gas to a solid it's called deposition. So this line here, this line that I just covered up here, represents a point where water exists as a solid and a gas, and they're in equilibrium. So it's going to exist as a solid and a gas, or the gaseous and the solid state of water is in equilibrium. The states are in equilibrium. Now, there are some other points that we need to mention, and we'll go ahead and I'll introduce them now, and then we'll talk about them in a little bit. So we have triple point, which is here. And as we see at a triple point, water or the sample is going to exist in all three phases at that point. So that's where it's in equilibrium. And then we have our critical point. We'll see that in a bit. The critical point, it's the temperature and pressure at which no phase boundaries exist. So at this critical point here, there are no phase boundaries. These lines that will represent our phase boundaries, where we have our solid and liquid in equilibrium, or solid and gas in equilibrium, or liquid and gas in equilibrium. There are no phase boundaries here. So anything above this point, we cannot ideally tell if it's a solid, a liquid, or a gas. So the critical point is the temperature and pressure at which no phase boundaries exist. So if we know what the critical point is, then we can identify our critical temperature and critical pressure. So the critical temperature and pressure would be the pressure and the temperature at the critical point. So for water, we see that the critical temperature is 374 degrees Celsius, and we see that the critical pressure is 218 atmospheres. So what is the critical temperature, or what is the critical pressure? So the critical temperature is the temperature above which the vapor cannot be liquefied. So at the critical point, if we increase the temperature still, that vapor will not be liquefied. It would not be turned into a liquid. The critical pressure, that is the pressure required to change a vapor to a liquid at the critical temperature. So at above this temperature increase in pressure, we will not be able to change this into a liquid. So here we've come to the end of studying the phase diagram, and the example we used was the phase diagram of water. So we've looked at the changes, we talked about phase boundaries. Remember, these lines are all phase boundaries, and it shows the points where the different phases exist in equilibrium. We've just talked about a critical point. We've also mentioned the triple point, which is the temperature and pressure where all three phases of the substance exist in equilibrium. Right, so that takes us to the end of this one. Until the next time, I'm out. Blessings.